And we are live. Welcome to another edition of Space Weather. Looking at the sun at 193 angstroms. We see a coronal hole rotating into view.
So you're telling me it isn't real? I had a fucking vote in a goddamn fucking Senate. That's a conspiracy theory.
No, guys, it's not a conspiracy theory. There really is a coronal hole rotating into the Earth-facing region here, which we can clearly see at 193 angstroms. And we are awaiting a magnetic connection with that, as it will spike the earthquake risk. Now, as I was saying,
You think you're fucking tough, you're about to get it. Bullshit. You're killing anymore, baby. Stop fucking loading. God fucking damn. I'm getting pissed now.
All right, guys, just relax. Everything's going to be okay. We'll look at the sun on 304 angstroms. There's no reason to freak out. Play some music, soothes the savage beast. We see a little bit of filamentary activity going on the east and western limbs there. And let's look at the magnetic lines. That's a pretty lousy view. Let's look at the different image of the magnetic lines. Please work. All right, full screen is not being cooperative. All right, let's see here. Let's pick a darker image. Here's a 94 angstroms view. You can see this canyon-like coronal hole and some active regions here with some magnetic complexity. Also, this does show you the structure of the North Pole coronal hole and the South Pole coronal hole, which are persistent at times of solar minimum, in case you weren't aware. All right, moving on. Let's look at the real-time. Look at the real-time solar wind here. All right, so we do see a couple 180-degree areas here, a couple little sputtering connections with that coronal hole. We'll see if that translates to any earthquakes. We also see a dip in the solar wind density here. It's all the way down to 1.93 protons per cubic centimeter, and we will see effects from that on the magnetosphere. And we got a solar wind speed of 401 kilometers per second. And let's move on to solarham.net, where we'll look at Sunspot 2734, which has degraded to alpha class, as there is no umbra, excuse me, there's no umbra associated with this negatively charged portion. So we've only got the one umbra, and you need two opposing magnetic fields to be considered a beta class flare. So that one's been downgraded. And let's move on to spaceweathernews.com. Get some more data here. We did see a B class flare there. Happened about midway through the day yesterday. Now, the Enlil forecast has been changed. It looks totally different now than it did yesterday. So let's just spend a moment staring at that. Leave it on the screen for you here. I tried to blow it up. I don't know why it didn't work. Where'd it go? It vanished. I guess if I blow it up too big, it makes a column or something. I don't know. All right, not being cooperative. All right, check it out. So the Enlil forecast has changed. This looks totally different. Yesterday we were seeing a CME coming like this and a CME coming like this, headed in opposite directions, kind of. I think my Epic pen is too big, folks. And now we just see one blob, mainly missing to the north. Keep in mind, the wind speed of this coronal mass ejection is estimated to be about 680 kilometers per second. So this coronal mass ejection, in terms of what it will do when it hits the Earth, is no more significant than a little pulse of regular solar wind coming out of a coronal hole. Anyway, moving on to some more stuff. We see the KP index is up to 2. There's your electron flux. Minor charging hazards there. And the F2 layer is looking pretty heavily charged there on both sides of the equator. And yeah, pretty big charge disparity there between the charged portion and South America, as we typically see around this time of day. Partially attributed to the South Atlantic anomaly. If you're not familiar with it, there's an anomalous region around here. And I guess I picked a bigger pen. Ha! Anomalous region around here. And we see it every day on this map. So let's look at Space Weather Enthusiast dashboard. Here's the Enlil prediction. Let's see if this shows something the same as it did yesterday, or if this has been changed also. Nope, this one's still showing 2 distinct CMEs there instead of 1. So significant disparity between the predictions here. And let's just look at the X-ray imager here, since we did have a B-class X-ray flare. See if we can pick that up. Looks like right there. It was about midway through the day yesterday, Universal Time, so it was right there, I think. There it was. Anyway, there's your little B-class flare. I figured I'd show that. And let's look at the total electron content forecast, as it's been a little high. We've been seeing some GPS errors in North America. I personally experienced one a few days ago. And the electron content is quite high. Quite high indeed. Usually we get a little bit more blue and a little bit less purple on this map. So especially if you're in the Pacific Northwest today, expect to see some significant GPS errors. And let's move on to geospace magnetosphere movies. Full screen these out for you. These load. Let me just see if I can get a pop-out chat going here. All right, excellent. And hello, Kalo Jan. Welcome to the live stream. All right, there's a pop-out chat. Nice. And we'll just head back to where we were. Nobody told you to maximize. You stay where I tell you to stay. Stay, pop-out chat. All right. So here's the magnetosphere movies. First, you got the velocity. Nothing too out of the ordinary there. You're going to see the white portion look like it puffs up here in the density portion. Keep in mind, the white portion of this is low density, folks. Low density. So we're going to see a very low density solar wind come in there, and you see this density drop way down. That's what happens when you get to about 2 protons per cubic centimeter. And here is the pressure view. We see higher pressure in the magnetotail than on the bow shock. So usually what you would expect when you get a pulse, a downward pulse in the solar wind density. Nothing too extravagant there. Let's move on to geospace ground perturbations. You like the way I switch tabs with staying on the full screen, folks? That's another value added, sir. Trying to keep the content as dense as possible. I, your host, smAsho, aka Dan, am also quite dense. Sometimes it's really tough for things to sink into my brain, believe it or not. So there's a geospace perturbations at the poles. Here it is over the globe. And while we're viewing this one, I just want to draw a quick little diagram here of how this works. So here's the sun, right? The solar wind is coming toward the Earth like this. As it arrives at the Earth, the magnetosphere splits this solar wind into field-aligned currents. Where they show up as Birkeland currents at the poles. In a fashion kind of like this. Meanwhile, this current goes all the way through the planet. The planet is moving through a magnetic field. And because there's electric current going through the planet, and because it's moving through a magnetic field, it creates a magnetic field. Just like the one on the sun, known as the B field. This is the B field on the equatorial plane, just like the sun. These are the Z fields, just like the sun. And I just figured I'd put a little diagram there to give you a little bit of an idea of how this works. The magnetosphere is what causes the field-aligned currents to split. And they show up here, they travel through the planet. And there's an inflow and an outflow at both poles, by the way. And that is how the magnetosphere works in reference to the solar wind. Now, we see the standard thing that we typically see here on these geospace magnetic perturbations. We see the South Pole kind of creeping toward Australia there. We see pulses into the Indian Ocean, as we always do. Also, we see pulses in the Atlantic Ocean. In the Pacific Ocean around Hawaii. And those of you not aware, we've got 2 North Poles. There's one up here, and there's one up here over Siberia. This one's a little stronger. And the South Pole is shifting like this toward India. All right, let's move on to whatever my next tab is. Look at the gong too. All right, so we are approaching the heliospheric current sheet crossing, which is right here where the green meets the red. And we still got a couple days until that happens. Otherwise, it's fairly smooth magnetic sailing. We are expecting the coronal mass ejection impact to be on the 11th. I would say early in the day, possibly even late on the day on the 10th. But probably probably early in the day tomorrow. We expect that CME to arrive and for it to be anticlimactic. Anyway, there's the gong too. When the heliospheric current sheet happens, we'll be reassessing. And let's look at the last 24 hours of earthquakes. We got a 4.5 in Japan there at 395 kilometers depth. So let me take the opportunity to draw in the earthquake watch zones as we are still experiencing a drought. So if you are in these areas, I should include that too. These areas here and these areas here, you are having a drought of 6 and 7 magnitude earthquakes. If you are in those areas, please have a plan. If some big disaster does happen, please be an asset to the people around you instead of a liability. All right. Also keep in mind, deep earthquakes are harbingers of larger earthquakes at the surface. So when you see a 4.5 at nearly 400 kilometers deep, you can expect to see a 5+ magnitude at the surface. Also keep in mind, folks, surface quakes are more damaging than quakes at depth. I also see a 4.8 in southern Alaska there. First time we've seen one there in quite a while, and that's a pretty big quake. Also a 4.7 in Indonesia, right in the warning zone. 4.2 in Tajikistan. 4.8 in Papua New Guinea, right in smack dab in the middle of the warning zone. And here's one in Mexico at a 4.7 magnitude. Chile with a 4.5 magnitude. There's a 4.9 at New Zealand. .8 in Argentina at depth. Now, by the way, people, after you see an earthquake at depth, what you're waiting for is a coronal hole magnetic connection, which we are already seeing a sputtering connection, and low pressure zones. So let's just take a moment to go to windy and look at the low pressure zones around that area, because this is how you really predict earthquakes, folks. This is not tinfoil hat made up nonsense. This is the real deal. So what you want to do is you want to look at pressure. And you want to look for anomalous low pressure systems that follow plate boundaries. So if that helps you, more power to you. Now, this quake so it's just east of San Juan, right? Sorry, west of San Juan. Anyway, the way you do this is you look for low pressure systems that follow plate boundaries. Now, for instance, we see this all the time out here, and I don't follow the weather in this area too much, but what we see here, now there's a plate boundary somewhere in this area that's like a 90-degree angle, and we see low pressure systems like anomalously moving around this plate boundary all the time. And that's one of the Ben Davidson techniques to predict earthquakes. If you're not familiar with it, head to quakewatch.net. And this site will explain to you the techniques: coronal holes, deep quakes, and anomalous low pressure systems. That's how we do it. Try not to spend too much time doing it because there's too much stuff to cover. So let's move on. All right, so we were at where were we? Peru, Argentina. All right, so there you go. There's that deep quake at Argentina. Here's another 4.6 at depth in Indonesia, as we see all the time. All these areas around Australia, folks, we see deep quakes regularly. Also another one in Chile, a 4.5 in Peru, all on the watch zone. So there you go. There's earthquakes. Let's look at volcanoes. Today, the list includes Karimsky, with a possible eruption, a 10,000-foot ash plume. Shivaluch, 15,000-foot ash plume, so a little uptick there. Produced a 34,000-footer earlier. So that's the biggest volcanic ash plume we've seen in weeks, folks. Shivaluch on the Kamchatka Peninsula. Looks like a new star has emerged. Also, we have a Biko producing a 12,000-foot ash plume there. Sakurajima exploded. And volcanic cloud, unknown, volcanic ash. Manam with a 15,000-foot ash plume. Popocatépetl. Volcanic ash detected in satellite imagery. And Revenador. 14,000-foot ash plume there. Salbancaya, intermittent emissions. And Planchon Petaroa, continuous emissions. So that's a volcanic uptick. By the way, if you haven't subscribed to our channel yet, please do. We are a growing channel, and we're growing in more ways than we're willing to mention in this video. So please head to youtube.com/smAshomash. Also, look at the links in the description for this video. Please support us through one-time donations on PayPal or through subscription services on Patreon. We are going to be putting up some pay-only services eventually when we get time to do it. But in the meantime, there's a lot of stuff in the works. So be prepared, because we're going to be putting out more videos, not less. Next, let's go to Galaxy Zoo at zooniverse.org, the largest citizen science project in the world. We need human beings to classify galaxies. You can get yourself published in an astronomy paper. Just set up a login. They'll use your real name, by the way. You don't have to use a nickname. And let's just show you what goes into it. Let's classify this one. It's pretty funky looking. We're going to say features because I see features there. Is it an edge on disk? Well, definitely not. Is there a bar? Well, definitely not. Is there any sign of a spiral arm pattern? Well, no, there isn't. Is there a bulge? You bet there is. How about, let's go with small. Is it merging or disturbed? I don't think so. We've just got foreground objects here. Foreground and possibly background. Now, it does look like a ring system. There could be a lens or arc. No irregular. We're going to say a dust lane. Lots of overlap. And we'll say something else because this satellite galaxy here looks like it's at the same focal point and is probably somehow interacting. So anyway, that's how you classify a galaxy. Head to zooniverse.org and please do so. Now, we were looking at the Enlil stuff as well as the signets, and they're a little questionable. Let's just let's look at a couple of them here. Let me see. Let's look at the Enlil density nowcast. I think this shows some interesting stuff. Oops, I opened two of them for no reason. Because we're looking at this CME, folks, and we want to see if it's, we want to see if they've changed the prediction on this. Okay. Let's move it forward to when the impact is expected and see what happens. And yep, it didn't load. And this is why I don't use this. Maybe I should be using it in Chrome browser. If anybody's messing around with it, please let us know. it is a good site. It does have a lot of information on it. While we're here, let's just look at the stereo A. Here's your stereo A. See if we can see anything on that. Looks like a little bit of activity up in this area. Anyway, by the way, if you're into cycling, check out theveloshop.net for all of your cycling needs. It is our official cycling team, and look for more of this in the future. Let's go back to the sun and show you some animations while I look up which articles we're going to cover, because there's some stuff in the news and it's relevant, so why not? All right. And where's my pop-out window? I don't see it. All right, let me just check the comments here. There are a lot of earthquakes in Alaska. Yeah, that's been a thing. My opinion on Zarkova's warning of a super grand solar minimum. Do I believe it will happen? I believe it will happen, but I don't believe this cycle is when it will happen, Mr. Raider. So yeah, part of the reason we're covering solar minimum is because it's a good time to teach people about how the sun works. So we're covering it, studying it extra in depth to see if we see any variables nobody else sees. Zarkova's predictions are a little bit more dire than ours. So as far as things like climate prediction, I'll just say that the Earth's climate takes a couple years to catch up to the sun. So let me just make this a pop out again. I don't know why it combined. For some reason it like got absorbed by the other window or something. I don't know. Google doesn't know how to write software. So anyway, Mr. Raider, I'm expecting cycle 25 to be occurring sooner than expected, and I'm expecting cycle 25 to be similar or stronger than cycle 24. So that might give us enough time to, as a human race, allocate resources a little better. And if it's a real grand solar minimum, it could be much worse than any we've seen in the past. So we're keeping an eye on things as best we can, and we're trying to inform people of the importance of solar activity, the magnetosphere, etc. Now, we got some articles here. First, we're going to go to Cosmos Magazine, because it's an interesting article about the mechanics of coronal mass ejections. So, couldn't be more relevant at the time to our channel. We will leave links in the description. We'll put all the links up here after the video is streamed. So come back to youtube.com/smAsho, click on this video, go to the description, and we'll have links to all these sites, as well as links to our other social media and so on. Basically, it's a chicken or the egg situation here. Do the magnetic ropes show up as a result of reconnection, or does the reconnection cause the magnetic ropes? It doesn't really matter, but it's good that somebody's studying this stuff. And yeah, so for our viewers, that's a good one. Mechanics of coronal mass ejections revealed. And there's still a lot of conjecture about this, people. This is not settled science. And things like the collapsing of double layers. If you're not familiar with double layers are layers created by magnetic compression, such as the F2 ionosphere layer. So anyway, there's that article. Also, we've got one from Universe Today. I don't think we've been here yet on this computer. And this is an interesting one that was also covered by Anton Petrov. If you're not familiar with Anton Petrov, he's a guy that believes a lot of stuff we don't believe, such as gravitational accretion and dark matter. However, he did a great video covering this. And what we're seeing is that the craters on Pluto and Charon do not appear to match up with the rest of the solar system, suggesting that there are no small objects in the Kuiper belt. So we see no craters smaller than 12 kilometers on Pluto or Charon. So that's an interesting thing. Now, are all these craters caused by impactors? Not so sure. Many of these look like electrical discharge craters. For instance, look at this one here. You see the way it has kind of a hexagonal appearance to it? That's not a coincidence. So anyway, an interesting article about the mechanics of mechanistic astronomy and the understanding of how the solar system works. We think the theory is that the Kuiper belt contains less small objects than the inner solar system. That's pretty much it. So maybe it's safer to be out there in terms of the danger of micrometeors. And we'll leave links to that article also. And let's play an old song from about 2000 here called Trance Schmance. Let's show you some current images here. We're going to show you just the sun today, universal time. So we'll give you the latest images here. If anything's popped off while the video is being made, you'll see it now. We'll look at 94 angstroms as this scope takes 5 times as many photos as the others. Oh, I see something. Check it out. We see one of these plasma sprites. There it is. We captured one during the live stream. Check it out. And it's not going to let me zoom. There it is. Oh, it'll let me open the image by itself. That's fantastic. See, I didn't even know about that feature. There's that sprite that's probably about, I don't know, 5 Earths in diameter or something like that. That's what happens when you look at the stuff. That's a good one. It's pretty far from the sun, too. I'm sure it probably only appears in 1 frame. So, anyway. Yet another benefit to viewing the sun at 94 angstroms. I don't know why the Google Chrome browser is so broken. Oh, okay. Wrong tab. My mistake. Yes, I don't think New Zealand is a safe place to relocate. It's in one of the most dangerous earthquake hotspots in the world. I mean, their buildings are built well there, but it's very desolate. I think you'd be better off in terms of if there's a major global disaster, you want to be on a continent, on a high mountain. Come on, software. Jeez. All right, let's look at another view here. We're not playing the music just to promote our music, by the way. Although you can find the music for stream or download at soundclick.com/goldencatproductions. All right, let's look at the colorized magnetogram to watch the evolution of Sunspot 2734 as it degrades to alpha class. Alpha class meaning it only has one field. Yep, it's degrading. The likelihood of solar flares is dropping. Although we do have a little bit of green leading edge there. Look at that. A little bit of extra complexity thrown in there in a reverse polarity sort of style. By the way, everybody's got mixed feelings about the function and the form. Everybody's got to elevate from the norm. All right, and let's look at the intensity gram here. By the way, if you don't put in new dates every time on this page, it will give you that error. I just forgot to do it. And there you can see little Sunspot 2734 on its way to setting. So I'd like to thank everybody for viewing. Please share on your social media. Don't forget to press the like button. Subscribe if you haven't done so yet. We'll be doing it all again tomorrow and possibly later today. Remember, when you're analyzing sunspots independently, don't drink. And if you drink, analyze the sunspots. Just don't drive.